Good morning and welcome to the What's New in Stella and I Think version 9.1 webinar. My name is Joanne Egner and I am the Managing Director of isee Systems. Joining me today is Kareem Shishakli, who is our Director of Product Development. Sorry, advancing the screen. After a few brief introductory comments, I will be passing the program over to Kareem, who will be spending the bulk of our time today demonstrating new capabilities in version 9.1. Concurrent with the release of version 9.1, we introduced the isee Netsim software, which is an add-on wizard for Stella and I Think that allows you to easily publish and share your models on the web. A couple of weeks ago, we did another webinar that we have recorded and put up on our website, and we're not going to duplicate any of the demonstration that was done there, but you should know that version 9.1, we added support for isee Netsim, and we also made some changes, some additions to button options and paging and whatnot relevant to creating interfaces for your models. So I encourage you to check out the recording on our website, and the URL is posted here. So now give us just a few seconds while we turn the mic over to Kareem.
Good morning. This is Kareem Shishakli, and welcome to our seminar. Glad you could make it today. We're very excited about version 9.1 because it adds some capabilities that make it easier to build models. They support the model development process. The most important modeling feature we added was the ability to break your model into smaller pieces, which we call modules. These modules can be developed independently by different people and put together into a whole model, or you can use it to decompose your model into smaller pieces that you develop separately. You can also reuse these modules from one model to another. You can share them with your friends, whatever. You can there's a lot of flexibility because each model is saved in a separate file, as we'll see. And you can also apply version control because of that. We'll be going through a bunch of these things today to show you. We also now support full causal loop drawing, traditional drawing. We had hybrid causal loop diagramming before, and now we've added full causal loop diagramming with both connector and flow polarity. Finally, we added some features to data import and export, which I'll quickly go over. The data import allows you to support multiple links, which we have here. So we might have multiple import links. So you may have a link for each different scenario that you're exploring, or you may have one import sheet for your base parameters and then additional sheets for different scenarios that you want to look at. In addition, we added the ability to export with settings that match the table that you've picked. When you pick a table up here, you're able to use table settings, and then your output in the table will match. The output in Excel will match the output from the table. So as I said, the features in 9.1 together better support the model building process, and the traditional steps in building a model are to first draw a reference mode, which describes the problem that you're trying to solve and sets the system boundary for you. And from the reference mode, you're going to then try to create a dynamic hypothesis. Your dynamic hypothesis is a causal loop diagram traditionally, and it is the minimum causal loop diagram necessary to explain the behavior you see in the reference mode. So it's usually only a few key stocks, right, or stock concepts. So we'll be doing this today, and then we'll build the model, which we'll do, and then you can verify the model against the reference mode to see that you're getting the expected behavior, and of course against extremes for robustness, etc. And the last two steps we won't look at today, but the last two steps, you'd analyze the model, you do sensitivity analysis of the parameters, uncertainty analysis perhaps, and you may add structure to explore policy options to see how you could fix the problem. The problem that we're looking at, this is the reference mode, and the reference mode, by the way, I built using sketchable graphs. I did a number of sketchable graphs and then printed them all together on the same graph so that we got a reference mode. So the reference mode, the problem we're looking at is the latest housing crisis in the last year. We've seen a lot of housing defaults, and why might this have happened? So we're looking at the problem. We're exploring in particular the hypothesis that lowering interest rates increases housing prices because now people can afford more because the monthly payments go down because the interest rates are lower, and that the effect of increasing the interest rate, increasing the interest rates later. If you increase the interest rates, this will then make it harder for people to continue to pay the mortgages if they had a variable rate mortgage, which many of these were variable rate mortgages. So if we look at this, at the beginning the interest rate is dropped by the Federal Reserve and demand goes up. As a result, the price starts to climb, supply starts to climb, and at some later point the interest rate is raised again, demand drops. Supply is going to take a while to react because there's construction underway, and it reacts to price, and the price is falling fairly slowly, really. And eventually it comes back at a new level. But what we see down here is that these are defaults in this orange graph down here, and we see the defaults are going up. And that's because these variable rates are coming due. And with the bank deregulation, with lowering down payments required, and extending mortgages over longer periods, 40 years instead of 30 years, and accepting applications when people could just pay the lowest rate that we've had in whatever 30 or 50 years. The rates going up made it unable for people to pay, and so eventually, after they're fixed, there's a 3-year fixed period on most of these variable rates where the rate didn't change. When the rate started to change, default rates started going up. So we'll explore that right now. First of all, to build a causal loop diagram, we're going to use modules, and modules are the fifth tool here at the top. It's a box normally that has rounded edges, but we want it to just be a name so that we can look at a traditional causal loop diagram. To do that, we go into the model preferences, and in the model preferences, we choose name-only modules. And now when I drop a module, it will have just a name. And the name that I will give it is we are going to look at housing supply. And we're going to look about how that reacts, how that interacts, I should say, with housing demand, and how that interacts with housing price. So as we build our causal loop diagram, we'll be using the connector. And the connector is right here and allows us to say, okay, well, supply affects price. How does it affect price? Supply affects price. As supply goes up, price goes down. So we will right-click on the connector, and we will choose polarity, and we will choose minus, opposite. As supply goes up, price goes down. So that's a negative connection. And as price goes down, supply will go down, so that's in the same direction. We would call that a plus. Now, by default, we use plus or minus here, but some people prefer S for same direction and O for opposite direction because it's sometimes clearer. And if you want to do that, under the model preferences, you can just use lettered polarity, and we'll get the S and the O instead. I prefer the plus or minus, so we'll stick to that for now. So we have what's called a balancing feedback loop here, and we can mark that with a label by putting a text box here and opening the text box by double-clicking, and choose this button, Format for Causal Loop Diagram, and press OK. When I do that, it assumes it's going to be a reinforcing loop, and it puts a plus sign, which is the traditional symbol for reinforcing. I prefer the B for balancing and R for reinforcing, so I'll just change that, and I'll number this loop also. I'll call this loop 1. On the demand side, as demand goes up, housing price goes up, so that would be polarity plus. And as price goes up, demand goes down, so that would be a minus. So let's label that also another balancing loop. I'll just copy that and I will paste it over here. I'm using the command key equivalents, but in the edit menu we've copy and paste right here. And I'll renumber that 2. And finally, how do demand and supply directly interact? Well, as demand goes up, people are going to be consuming that supply, so the supply will go down, so that is an opposite direction as well. And that gives us one more loop here, which I will paste this thing back in again, and we'll call that loop 3. That is our dynamic hypothesis. Under some circumstances, we also would like to look at exogenous inputs changing this, in which case I would use a converter. And we can implement what we call name-only converters to do this. A converter normally has a circle attached, but if I go into model prefs, I can choose name-only converters here to draw causal loop diagrams, or I can right-click on the diagram and choose name-only converters here. And I can say, okay, let's say interest rate. Interest rate is an exogenous input that's going to affect demand. As interest rate goes up, demand will go down, and so that's a minus relationship. So I could do this. In this case, I'm not going to do this. I've actually put interest rate inside my housing demand module, so we won't do that. So here's our dynamic hypothesis that we hope explains our reference mode. We can actually walk through this and see that it does. We don't have time to do that today, but we can walk through and see that this does adequately explain the reference mode that we had before, except for the defaults, because there are no mortgages in this dynamic hypothesis at this point. But we want to start small. So now we want to build a model. When we want to build a model, the nice thing about using modules here is I can then go into here and I can go to the model prefs, and I can say, I can turn off name-only modules, and I can start building my model directly from here in pieces. I can build housing supply first. I'm just moving the names to the middle. I'm holding down the control key and I'm dragging the name to the middle because I like that feature. And I can start building my model from here. Before we do that, though, let's go over a couple of things. So there are several icons that we use to look at modules. The first one you've already seen is the module icon, and the modules are connected. In this case, demand is connected to supply with a connector. And that means that I can take values from within the module housing demand, and I can use those values in housing supply. In order to use a value in housing demand, though, I have to say that this is something I want to be used as an output that other people can access, that other modules can read. So otherwise, every variable would pollute the space, would look very awful. So I specifically choose which variables inside housing demand I want to use for using other modules. So in this case, I have a variable called demand that I implemented as a converter instead of as a stock, and I made that a module output in housing demand. In housing supply, I have to, which is going to take that value, I need a variable that actually takes that value. And so I have a variable that I place in there called demand, and I've marked it as a module input, and we'll see how to do that in a minute. And when it's marked as a module input, that means it'll take a value from somewhere else. It has this bold line around it that says, okay, this I know is going to come from someone else, but it isn't connected yet. So it's unconnected, but I want it to be connected at some point. So the bold just reminds me I need to go back and do something. I'm not done yet. And in fact, if we try to run that model at a higher level, it won't run. But in the module, it will run. Once I assign it, it appears like a ghost with a thicker line. It is, in fact, essentially a ghost of demand for houses. You'll notice the name has the name of the module, a dot, and then the name of the variable. So the module is housing demand, the variable is demand for houses. So this variable is now assigned, this input which was up here is now assigned to housing demand dot demand for houses. So you'll see that those icons as we work through this. Let's go back and So here is our model, more or less. If I were to start building this, I would start by trying to define these modules. And you've noticed I've gone from map mode to model mode, so it's telling me I have some things I need to do. I need to, there's no models been imported here, and there's some entities that are invalid here. So let me assign a module to this. If I were building this from scratch, the first thing I would do is I would create the model that goes in here. And when I do that, I would give it a name, and I'll call it housing supply, sorry. And save it. And what that did, by the way, is that put it in a folder called modules. And so this folder modules exists in the same folder as my model. This is my model, supply and demand, and these are my modules. When I send a model to someone else, my model is not just a single file anymore. It is the single file plus the folder of modules. So if I want someone else to use my model, I need to send them both of those pieces or it won't work. So now that I've imported that, it's just an empty model. And I can start building it just as I would build any model. And I can say, okay, this is houses available or whatever. And then I have an inflow of constructed houses, right? Whatever I want to call it, doesn't matter. And I have, my real estate turnover, right? So new things, and those are houses available, and somehow demand affects it. We're not going to build the model. We don't have time to do that in this session. But what we will do is I've already built this model, so I'm going to reopen this module, by the way, I'm holding down the control key, and I'm double-clicking to get to the dialog, because a double-click just opens it. I'm going to actually import a model that I've already built for this, and it's right here. It's an ITM file. And of course we want to replace it. So let's go into this. And so now I have this module here. And I didn't tell you this last time we were in here, but we can notice that we're inside a module because the interface tab is gone. We have these two buttons at the top. The first one says to go up one level, and the second one takes us to the top level, home. And the reason there are two separate buttons is you can have as many levels deep as you want. We're only showing one level in this particular model. So the buttons do the same thing. The other thing you can tell is at the top here, we have the name of the module that we're in, and if we're down several levels, it has a path to where we are. We'll show in the title bar so we know where we are. So here we have our housing supply module, and in this module we have these three variables here that I've marked as wanting inputs from elsewhere, but they're not connected yet. And in fact, if I go to run by module, I can run just this module by itself without running anything else, and I can test it and I can verify it works, and we can see, for example, that we initialize it to equilibrium as we would like to do for our models when we start. And we can test this module by giving it a step input in price. We can change the price, which is a traditional way to test the behavior of a model. And we would expect if price goes up that the number of houses available will also go up, and of course the number of houses being constructed also goes up. So the model's behaving the way that we hope it would behave. Now the way that I made these inputs, by the way, is I right-clicked and I said module. Under the module menu we have input, accept input, provide output, or do neither. So I can turn this off or I can turn it on. These are all set to accept input. And also under here I can assign these inputs. Now these inputs want to come from somewhere else. The price needs to come from housing price, and in fact there's a variable called housing price in the price module. So we'll connect to that, and normal price will come from the same place, so we'll connect to that. And demand comes from the demand module, so we're going to connect to the demand module. Now those I've already pre-built because for the sake of time. And before we go any farther, let me turn off run by module, because we'll get confused later because it won't work. Okay, so let's go back to the top, and we still have a question mark in price. Price has a question mark because if we look inside, we'll see the supply to demand ratio is not defined, and the reason it's not defined is because we only have demand, we don't have supply. Now I used the right click a second ago to assign these things, but we can also use the ghost tool instead. So I'm going to show that. I can use the ghost tool, and I can take houses available, which is the supply, and I can bring it into housing price, and I can drop it here, and I can move the name to the bottom, and I can connect it in. Now, this is an input that's already been assigned. If there's no connector missing, it's already been put in there. And the source, which was houses available in housing supply, has been made an output, which we'll see in a second. We'll need to fix this equation so that it actually works, so that it has supply divided by demand. And we have a running module now, which if we ran by module wouldn't do anything, but we're not running by module. By the way, let me just very quickly show you that houses available is now an output. I have this box around it inside the, which looks like an O on a converter, sort of like a square O on a stock. So that's an output. At this point, we can run this model. It's a fully functioning model. We'll need to add supply in here because it wasn't here. So supply is under housing supply, houses available, and we'll want to set that scale to match demand, which was 80 to 180. And we'll also probably want to just see the interest rate so that we can see what happens. And the interest rate, I said, is in the demand sector. So we'll, oops, I didn't hit the right thing. Oops, I did hit the right thing, sorry. Here, let me do that again. I just took out the wrong thing. Houses available, interest rate. Okay, there we go. And 80 to 180. Okay, and if we run this, you know nothing interesting happens. But what if we drop the interest rate at the beginning of the simulation? You will see that something does happen, and if we raise the interest rate again after some point, we'll see that something else interesting happens. And in fact, we won't go through this in any great detail, but you should see that our reference mode has been reproduced. Demand goes up right away here, and price starts to rise, supply then rises to meet demand. When we raise interest rates, supply overshoots, demand drops right away, and price eventually tries to catch up. So we have matched that. We don't have the defaults. I'm going to go to an alternate model that I've put together that has the mortgage stuff in it, just so that we can see that, and we can demonstrate modules within modules. So here I have a separate model. I'll just show you it's a slightly more complicated model. Housing demand translates to mortgage demand, which then affects the supply because you can't buy a house without a mortgage traditionally. And I have this little switch here for bank deregulation, which I'll turn on. And we can watch what happens if we run this. We'll decrease the interest rate and watch what happens, right? Everything goes up as we expect. We can increase the rate a little bit. And of course, things should go a little crazy. Notice we're starting to default down here. And then we can increase the interest rate a little more. And we can watch what happens as this plays out. And I'm not going to show you due to time constraints, but even if we decrease the interest rate now to make up for this, because of the problems that are in the pipeline with approving mortgages that shouldn't have been approved, decreasing the interest rate does not reduce the default rate. So we won't go through that. What I am going to show you is notice the price changes quite a bit throughout here. And if we want to track what the highest price was, we can go into here and we can use something I have over here. Let me find it so I can show you. I have a little model that I made that calculates the maximum value of any input. So I have an input that's defined to be a module. This is a module input from somewhere else, and I have an output which is the maximum. So I'm going to use that in here. I'm going to drop another module. I'm going to call it house price, because it has to have a unique name. I am going to import that maximum value model that I just showed you. And in case you don't believe me, it's right there. And now that we're down here, you'll notice that we have two levels in the title bar explaining where we are. If we move up, we have to assign this input and we have to assign this output somewhere, or we can't run this. So we can do that strictly from here. We don't need to go into here. If we know this is a maximum value function that we've put in this module that we can reuse over and over again, we can just go in here and we can connect it, and we know it has one input, and we're going to assign price to be that input. So price is going to be assigned to that input, and we know it has one output, so I have a connector from its output, and we're going to assign that to the maximum. So now we have house price maximum here. So we can now go back to the top, and we can do the same thing. I'll just take off defaults, and we'll add in house price maximum, which is in here somewhere. House price maximum, and we'll scale that the same as the other prices, which is 60 to 200. And when we run this, we'll start from a straight place again. Oops, sorry. I didn't mean to do that. We'll run that from low interest rate again. There we go. So it goes up, and then we'll raise the interest rate, and then we'll raise the interest rate again. And just to see how it plays out, you'll notice the maximum rate tracked as it went up, and it stayed up there. It never went down. It's in orange right up here. Okay? So, to wrap up, modules have many benefits. They allow you to break large complex problems down into smaller pieces. They allow you to version control your separate pieces. They allow you to build your model in a way that's consistent with the traditional way to build models, where you build a dynamic hypothesis and then work down and build up the detail in each of one of those sectors or modules of the dynamic hypothesis. They allow you to share the modules with your friends. They allow you to test the pieces individually. So these are all important benefits for us, and will greatly improve the ability to build models. I am now willing and open to take questions. So we'll wait here a second while some questions come across. Okay, so the first question I have is, why doesn't housing supply rise in line with defaults? In fact, housing supply does in fact go up with defaults. It's hard to see in that model, and unfortunately we won't have time to explore that today. But the defaults feed back to the housing supply in that model. So in fact, supply should be going up, but you'll also notice that the defaults are smaller in magnitude than the supply that's already there. We can of course play with that and make those numbers different and have it have a larger effect, which it probably should. Okay, is this housing model available on your site? It is not yet available on our site. It will be available on our site. If you would like it before it's on our site, please feel free to email us and we'll be happy to send it to you. Do the graphs represent real data or hypothesized data? In fact, the graphs are completely hypothesized, and that is one point I want to make about reproducing behavior of a model. I'm not trying to reproduce the exact system. I'm trying to test a hypothesis about what is happening within the system and what the implications of that may be. I don't need exact numbers in that case. I did use interest rates that are in fact pretty close to what are the real interest rates. I did in fact use a housing value that it was the average housing value was close to the real housing value in thousands of dollars. So I did use some parameters that were fairly close to the real numbers. The supply and demand are completely made up numbers. I didn't look for the actual numbers. I could modify it to use the real numbers, but it's more a qualitative model than an exact calibrated quantitative model. Do the reference mode represent hypothesized behavior over time? Yes, and in fact, they represent, traditionally they represent historical behavior up to a point, and then hypothesized behavior after that point. In this case, this has already happened, so we have seen this behavior, and what is hypothesized is that the interest rates are in some way, and the bank deregulation is somehow driving that. So that's really the hypothesis in this model, not that this will happen, although we could have built this model a year ago and we would have gotten the same results, whether or not we hypothesized that that's what would happen. Is there a balancing loop between housing supply to housing demand? And yes, the answer to that is definitely a yes. It goes through price, though. It's not direct. How many nesting levels are available? We have as many as you need. There's no limit inherent in the program. You'll run into limits with memory or disk space or whatever. So there's no practical limit for what you may want to do. How is the module concept different from the submodel concept of a couple of versions earlier? That's a very good question. And another good question would be, how is it different from the sectors? Let me talk about the sectors first, because the module actually replaces the sector in a way. Modules and sectors are very closely related. The difference is within the module, using modules, you're able to capture the dynamic hypothesis right at the top level of the model in a causal loop diagram. You could do that more or less with process frames at the top level, on the interface level, with sectors. But with modules, it's just captured right there on the model, and it's much simpler. You can also do multiple levels, which you cannot do with sectors. In addition, you can share your modules with other people just by passing the files around, which you also cannot do with sectors. How is it different than submodels? Submodels are, again, are the same idea, but they're only one level deep, and submodels specifically required a inflow and an outflow, which modules do not. You can, of course, have flows between modules, but you'd connect them with connectors and using cross-level ghosts, module inputs and outputs, just as you might between sectors. Do the run specs have to be the same for each module? Long-term, the answer is no. Short-term, the answer is in 9.1. Yes, they are all the same. However, it's been programmed to allow us to relax that restriction in the future. Are there any changes to sectors in version 9.1? No. Any preferences to using modules versus sectors? Again, if you're building a dynamic hypothesis and you draw the causal loop diagram, you can just turn that causal loop diagram into a model directly just using modules. And if you have several levels deep, then you're not going to want, or a complex model. Sectors are more cumbersome. For a small model, I don't think there's a large difference, and you can easily translate between sectors and modules. Let's see. While I'm waiting for other questions, I'll just show you our contact information, which is right here. My email address is at the bottom if you need to send an email, and so is Joanne's if you have other questions. And I'll remind you that we'll be sending all the questions and the answers around in an email to everybody, as well as posting the webinar on our website. We've seen the benefits of the module framework, but can you show us the equations? Someone wants to see the equations. Great. Let's go look at the equations. Here are the equations, and you'll notice the listing looks very similar to a sectored ordered listing of equations. So there are the equations. If you need any help upgrading, feel free to email support@issystems.com to get 9.1. If there are, I'll wait just a minute to see if there are any further questions. Okay. We're getting a number of questions, and we'll sort through the questions as we after the session in order to end on time. So thank you for joining us today. I hope this helped you figure out how you can use 9.1 to your advantage, and help those of you who have it how to use some of the features some of the new features. Thanks again for joining us. We'll be sending you a list of the questions that we received with all the answers, and again, we'll be posting this webinar tomorrow. Thank you.